Hi, in this video I'm going to go over example 17 from your textbook. Go ahead, pause the video and make sure you understand what the question is asking us to do. Okay, welcome back. So the question has already given us S of t, right, which is a function of displacement. And for part A, they want us to find the velocity. So I hope you guys remember that velocity is basically the first derivative of my displacement function. So for part A, for me to find the function v of t, what I'm going to do is just find the first derivative of my displacement function, and so my v of t is equal to 2 minus 2t. Okay? Part A should be alright. Now for part B, they want us to find when is the particle moving to the right and when it is moving to the left. Alright. For this, we need to recap on the fact that when my velocity is greater than 0, what does that mean? When my velocity is less than 0, what does that mean? Right? So I hope you guys still remember this. We talked about this when we were first learning about derivatives, right? So when my velocity function is greater than 0, which means positive, my object is going to the right. And if my velocity is less than 0, that means my object is going to the left, right? So, which means I'm going to use my v of t here, my v of t, 2 minus 2t, to help me out, right? So, I'm going to make my v of t and make that equal to 0, and I can solve for t, which means when t is equal to 1, my velocity is 0, right? After that, what I'm going to do is kind of create a sign diagram that shows when does my object goes to the left and to the right. Alright, so here I have my sign diagram. This is v of t, and my special value is 1. I put that down there. So I've also put down 0 here because the question says t is greater than equal to 0, right? So I've also put down the value 0 over here. Alright, so I'm just going to simply analyze the sign of my v of t in these two regions, right? This region here and this region here. So just put in some random test values. Let's say if I test this with 0.5, 0.5, if I put 0.5 in v of t, so v of 0.5 gives me a positive value, right? 2 minus 1, which is positive value. That's what we care about. And if I test this with maybe a value that is 2, so v of 2, 2 minus 4, this gives me 4. This is 4 here. Right, so 2 minus 4 gives me a negative number. So that's all I care about. I only care about the signs. So now I have my sign diagram completed. That means from 0 to 1, my object is going to the right. From any time after 1 second, my object is going to the left. Okay, so this is going to help me out in part C. Part C, they want us to create a motion diagram, right? A motion diagram. Alright, so in order for me to draw the motion diagram, I need to first know where is my particle at the very beginning, or in other words, what is the displacement when time is equal to 0, right? So let's find that. Let me scroll down a little bit. So S of 0 gives me the displacement when time is equal to 0, which is just 8, right? That is just 8 from here, from the top, right? S of t is equal to this, and since my t is equal to 0, my S of 0 is equal to 8. And let's find a few more points. So here, since my my other special value is when t is equal to 1, from here, from the previous part. So let's say let's find where exactly is what exactly is my displacement of my particle when time is equal to 1. So let's put that in. So 8 plus 2 and then minus 1, which is equals to 9. Alright, so now I have a better idea of um, the displacement of my particle at this time. So, and from part B, I already figured out when does my particle travel to the right and when does my particle travel to the left. So I'm going to use the information I have here to draw this motion diagram that I have on the right over on this side. So let me use blue. So when time is equal to 0, my object is 8 units away from kind of the origin. Alright, so I'm going to put an 8 here. Oh, sorry. So this is when time is equal to 0. Time is equal to 0. Let me just put that down in parentheses. Okay, time is equal to 0. And when time is equal to 1, my object is at 9, right? My object is at 9 when time is equal to 1. So this part shows that my object is going to the right. And then what's gonna happen after that is after 1 second on this side over here, I know that after 1 second my object is going to start going to the left. So my object started from here, goes to the right 1 unit, and then starts going to the left. Alright, and then never comes back. Right. So that's it. This is my motion diagram. Okay. Alright, so we're done with A, B, and C. Now for part D, they want us to write definite integrals to find the change in displacement and the total distance traveled on the time interval from 0 to 4. Okay, and then later on we also need to use GDC to evaluate the integrals, and then also use the motion diagram to kind of verify the results. Alright, so we have a bunch of stuff to do here, but let's just start with finding the displacement. Alright, let's do that first. So let's scroll down a little bit, have more space. So for the displacement, we are talking about from 0 to 4. Right? So displacement, we don't really care about how far did we go. All I cared about is where is my object when my time is equal to 0, and where is my object when time is equal to 4, and how far they are from each other. And that's all we care about, right? So for the displacement part, we're kind of saying that from the location of my object when time is equal to 0, I'm going to move from there to the location of my object when time is equal to 4. And what is that displacement? Right, so that's it. And but they want us to use definite integrals to do that. So this is how we do it. Definite integral from 0 to 4, and we're taking v of t. Alright, so v of t is equal to 2 minus 2t. So let me copy that down. 2 minus 2t. Actually, in fact, we don't really have to do that. So we're taking the definite integral of v of t with respect to t, right? And this is basically if I take the integral of my v of t with respect to t, I get my s of t, right? I get my s of t. And what I'm doing here is I'm just evaluating my s of t from 0 to 4. Alright, so this is just s of 4 minus s of 0 minus s of 0. S of 0, we already found this. S of 0 is equal to, how much was it? S of 0 is equal to 8. And SL4, I will have to evaluate that. So SL4 is equal to, so let's go up and we'll come back down later. My S, so this is my displacement function. So 8, so my T is equal to 4, so 8 plus 2 times 4, which is 8, so 8 plus 8 is equal to 16, minus 4 squared minus 16, so that gives me 0. So SL4 is equal to 0. So 0 minus 8, I have negative 8. Alright, so let's take a look at the motion diagram and see if there's any connection between what I just found, the negative 8, my displacement of negative 8, to my motion diagram. So what I'm looking at is, let me use green. Okay, let's use yellow. So when time is equal to 4, my object is at somewhere, so from here, S of 4, which is 0, that means my object is at 0 over here, when time is equal to 4. When time is equal to 4. So how far is that away from my object when it was time equals 0? When time is equal to 0, my object is here. Right? So I'm moving from this place to that place. So obviously I'm moving to the left. That's why I have a negative. And then how many units am I moving to the left? 8 units. So that's what this negative 8 means. Okay, so and this is the part where the textbook wants us to use the motion diagram to verify the results. Right? This is displacement. We just talked about displacement. Alright, so we're done with the displacement. Now we have to find out what is the total distance traveled. Right, total distance traveled. So let's find the total distance traveled using the integral first. However, we have to keep in mind there's something that we need to be careful with, right? So from time is equal to 0 to time is equal to 1, I moved one unit to the right. Right. So from 0 to 1, the distance traveled. Let me put that down. From time is equal to 0 to time is equal to 1. My distance traveled is 1 unit. And then from t is equal to 1 to t is equal to 4. So from t is equal to 1 to t is equal to 4, t is equal to 4. I moved to the left about 9 units, right? 9 units. I don't really care about the directions. I only care about how far I've moved. So the total distance is equal to 1 plus 9, which is 10. Okay? Alright, so that's how we use integrals to find displacement and total distance traveled. I hope you guys understood this example. See you guys. Good luck.